papers in some form, often with some deviations from it. So this is a typical article in my field, so in geophysical research letters, which is a short letter format journal, usually 5 or 6 pages. So title and authors listed at the top, abstract, introduction, methods, results, discussion, sometimes grouped with conclusions, and then references. So every paper, every primary scientific paper follows this structure to some degree, but there are variations. Especially in environmental sciences and earth sciences, the methods are often replaced by a description of data used or a model used, for instance, from satellites or climate models, or can be replaced by a theoretical derivation of a new result. Often papers in our field don't involve going to a lab or something, so it can be a theoretical derivation. Results and discussion are often combined, especially for theoretical or numerical papers. This is rarely done for experimental papers, where usually the results are presented and then their meaning is discussed. Sometimes the conclusion is omitted, especially for shorter papers. Generally, conclusions are repetition, information that's already in the abstract or the discussion. Yes, you're welcome to record this presentation. Put a comment. So very short papers, such as in high-impact journals, Nature, Science, Proceedings of the National Academy of Sciences, they often do not have headings. So there, it still often follows, intro, methods are usually skipped, put placed at the end, and then results, discussion, but they don't have headings, so it's sort of implicit. Okay, so that's sort of the background on scientific literature. Now let's talk about reading it efficiently, which is really, really important if you are going to be efficiently doing research. So the biggest mistake that people make in reading scientific papers, or proposals for that matter, is to read it like a book. Scientific papers are not books. They're not novels. You're not meant to read them linearly from abstract to introduction, through methods to results. So don't do that. That wastes a lot of time. Instead, what you should do is you should first read the title, of course, abstract, and then look at the figures and the tables. Figures are meant to be standalone. Well-written papers, you can understand at least the basics of what a figure shows without reading the rest of the paper. So look at those, look at the title, abstract, figures, and then ask yourself, okay, what is this paper about? What are its main conclusions? And is that interesting to me? Is that important to me? You want to answer that question as soon as possible, right? Because you want to figure out if this is a paper that is worth investing your time in to really understand, or if this is not important to you, in which case you can just let it lie, or if you just want to absorb the main point of the paper, right? And for that, you don't need to read all the methods. You don't need to read all the results. You can probably just read the abstracts and look at the figures, right? So you can save yourself a lot of time. So if you do find after that the conclusions are important enough to your project that you need to really understand what allowed the authors to reach that conclusion, then you should read the rest of the paper. Then you should read the introduction, results, discussion, and if you're really interested, read the methods. But often for most papers I read, I certainly don't read the methods. I just get a general sense of them without really understanding all the details. It costs a lot of time. Okay, so let's go over each section in a little bit more detail. Right, the abstract is most important, right? That's the summary of the paper. You can get most of the main points of a paper for just from reading the abstract carefully. So then move on to the figures, right? Figures are really efficient in communicating information, right? Much more efficient than written words are. So a picture is worth 1,000 words is really true. So after reading the abstract, look through the figures, read the captions, and well-written papers, you can understand the figures, at least to some extent, right? Poorly written papers, sometimes not so much. So sometimes, especially if you're reading a poorly written paper, you have to consult methods and results to clarify the confusion with the figures. That also depends on how interested you are in the results. If you want to just get the main point, maybe you don't need to. If you really want to understand the details of the paper, probably you need to refer to the methods and results. Right, so after going through the figures and understanding what's shown there, you should have a good idea of what the paper is about and what the conclusions are, what this paper adds to the body of scientific knowledge. Okay, so after you've done this, so this is a repeat slide, right? After you've done this, ask yourself, okay, is this paper important enough to what I'm trying to do that I want to invest in, additional 2 to 8 hours or something to really understand this paper, right? And then you read through the rest of it. So introduction, results, discussion, methods. I personally do this with maybe, 1 in 10 papers or so. Okay, so if you decide to do that, the most useful part of the paper after the abstract in the introduction is after the abstract and the figures is the introduction. And that's because the introduction presents background information. So to help you understand why this research is important. So basically communicates more than just the main points of this paper. So well-written introduction presents how the specific topic of this paper fits into the big picture, right? And that connection is really important. You can learn a lot from understanding that. So it goes over past work in the field that is relevant to the question being studied in this paper. So it often does sort of a mini review of relevant past work. And then it goes into topics that are more specific to this study. So what the paper's hypotheses are, why those are important, and what the paper's main conclusions are. So this is, I love reading introductions. If they're well written, they can be a tremendous source of information. And so unless you're already like an expert in the field, so maybe midway through or the end of your PhD, and this paper is squarely within your expertise, it's usually a good idea to read the introduction carefully. You can learn a lot from that. Okay, then methods. This describes, of course, the methods used to investigate the research question, which in our field varies widely, right? Laboratory field measurements, data analysis, analyzing models, climate models, satellite data. So the methods are written for that small subgroup of people that might want to reproduce the results or parts of the methodology. So most people reading this paper don't need to understand the details of the methods, just a general approach. So methods is the least read section of a paper, and that's why journals like Nature and Science put them at the end for efficiency. Moreover, because science builds on itself, it is not feasible to fully explain all the methods in the paper. So often there's citations to previous work that describes the methods. For instance, climate modeling papers will not give a detailed 300-page description of the climate model, right? They'll just cite a publication that does. Okay, results refer to the figures and tables, and they describe objective conclusions that can be drawn from them. In other words, 10 educated scientists looking at the figure would sort of write the same results section. They would draw the same conclusions from the figures. So they're objective facts. For instance, figure 1 shows that X is greater than Y, but that's where it stops. It does not discuss why X might be greater than Y, because that involves interpretation. Those are not objective facts. And those are saved for the discussion section. So, similarly to skimming the figures, after reading the results section, to really understand the paper, you should ask yourself, okay, what conclusions can we draw from the results, right? What interpretations can we draw from the results? Which is the topic of the discussion section. So in the discussion, the authors interpret the results and draw inferences of what those results might mean, right? And that's subjective to some extent. So discussion sections are usually the most controversial of the paper. Authors will link this back to the introduction, in which they laid out the bigger questions that motivate this research and the specific questions that they're studying. And so in the discussion section, authors will discuss explicitly how the results in the results section answer or don't answer the hypotheses or research questions discussed in the introduction. And so usually the authors will also couple it back to the big picture that motivated the work. At least a well-written introduction will do that, or a discussion will do that. And authors should always discuss the limitations of the study, and often they will suggest future work needed to more fully address the research question. So in other words, when you read the discussion, make sure that you separate the facts, those are presented in the results section, from the author's opinion or interpretation, right? And if the paper is squarely within your field, you can probably draw different interpretations than the authors. You don't have to agree with the author's explanations or interpretations. It's very likely they're wrong. It's just their best guess or the educated guess at what they think the results mean, and you might have a better idea, in which case you can write a paper on that, right? So discussions are not facts, generally speaking. Okay, any questions? Yeah, maybe you can pull up the chat so I can see if there's any questions there.
There is no particular question. It's just
I see.
Links for the slides.
Okay.
Keep in mind that you can unmute yourself. You can unmute yourself if you have to talk. So if you have any questions, just unmute yourself and talk.
Right.
Any question?
Yeah, I've got a question over here.
Okay, I'll keep going then. But yeah, feel free, of course, to interrupt. Okay, so how to find scientific papers then, especially free ones? So when you start researching,
okay, there's a question.
There's a question. Okay.
Bastien. Bastien, go ahead.
Yeah, can you hear me?
Yes, I can hear you now.
Right.
I'm sorry, you're cutting out. I can't hear.
You type their message.
Maybe you can chat it. You can type your message. I think that might be better.
But in the meantime, can you also try again? It seems the connection is bad.
Yeah. Can you cover literature?
Just explain yourself.
Can you cover the literature section?
You mean the reference?
No, not the reference, the literature. Like he went through introduction and then went to methodology, not the literature. So I want to understand relative people. Yeah. Can you hear me?
Yeah, I think he's asking about you going over the literature part, right? Is that what you asked?
Yeah. So what I want to look at, in your literature, most of what you'll have there will substantiate your discussion of your results. You'll keep on referring to your literature in terms of discussion. Now, what I want to understand is that can you just go a bit over the literature and also how it links to the methodology?
So the literature.
That golden thread from drawing from your literature, then moving into your methodology.
So what do you mean by literature exactly? Do you mean literature review?
Yeah, literature.
I see. Yeah, literature review is kind of a misnomer in some sense. So a lot of papers in the introduction do a literature review. But for instance, if you read papers like in Nature or Science or like really well-written papers, most papers just discuss the science that is needed to understand the results in this paper. So they don't necessarily do literature review. They just they discuss enough of what has already been done to put to identify the gap in the literature that this paper is filling and to help interpret the results. So that's usually done in introduction, and then in the discussion session, sometimes that's referred back to.
So just to comment a little bit, I kind of get a little bit why he's asking that question.
Okay.
So, for example, before I moved out of Nigeria, there's a typical way people usually write papers or thesis, I think, is that, so it's talking about thesis, yeah. So the typical way is that you write introduction, and then there's a whole chapter on literature review. You get what I mean? So that's so there's a whole chapter on literature, which is
you mean like a paper in a class or something, or
yeah, just like a summary of every other paper. And typically, the way say students in Nigeria that I'm from usually do it is just dump all the papers that whether it is sometimes relevant, sometimes not relevant. So I think what it's trying to ask is, what's the so if you imagine a typical summary of say previous work that people usually write in paper, like how is the best way to write that in a typical literature review? As you mentioned, one point is that you focus only on the papers that are relevant to what you want to talk about. Yeah. You already mentioned that, but what are the other points, for example? I think that's probably the question it's asking. Bastien, does that is that similar? Is that right? Bastien, is that right?
Mute. His question, yeah, you're right, is saying, is how do you choose or evaluate what is relevant literature to support the paper?
I see. Yeah. Okay. That's difficult. It depends on you need to be able to articulate the gap in the science that your paper is filling, and so you need to, in your literature review, you need to discuss enough literature to make it clear, where the gap is. That makes sense. So you want to only discuss papers that point out or that indicate like where the gap is in the literature that your paper is reviewing. You don't necessarily, at least in a scientific paper, you don't necessarily want to give a whole review of an entire topic. Like you just want to focus in on that part of the topic that has not been addressed. There's a gap. There's something that's not known. And then you want to just introduce or discuss the papers that sort of give information on what that gap is. Literature review relevant in the results section. Right, so literature review should, so most papers don't have, a section labeled literature review, right? So you review some literature in the introduction. In the results section, you would not review any other literature, because in the results section, you just give your results.
For example, like let's say you're writing about your model. Would you write about your model in the literature, or would you write about your model? Like this is a thesis now. Would you write about your model in the literature, or would you write about your model in the methodology section?
In the methodology section. Yeah.
So you wouldn't review your model in the literature to justify why you are actually choosing that model?
No. Yeah, not usually. No, you would discuss that in the methodology section. In the introduction, you would specify the question duration. Right, so you get the curiosity of the reader up of like, there's this big open question that's never been addressed, and you want to define that really well in the introduction. You want to cite, relevant literature that defines that gap, and then in the methodology, you would introduce the methods you use. So that includes the model you're using.
Does that answer your question?
Yep. Question answered.
Great. Okay. So where was I? Okay. So finding free scientific papers. Okay. So first, of course, you need to get familiar with the topic you're studying. I know a lot of you already are fairly far along. Some of you are not. So if you're starting a new topic, a great first step is not looking at the primary scientific literature, because that's dense. It's harder to absorb. It tends to cover, very small pieces of science. So a great first step in researching a new topic is to read, for instance, relevant entries on Wikipedia. Wikipedia is a great source of information, but you have to use it carefully, in that Wikipedia is not nearly as reliable as primary scientific literature, right? But it can provide great summaries of scientific topics. So you need to, judge a little bit. So science that a Wikipedia page is relatively accurate or not accurate is one, it cites many sources, and those sources are from the primary scientific literature, so they're in scientific journals, right? Those citations are also a great place to start to find your own scientific literature related to the topic. Articles in Wikipedia that are not accurate or that are not like a large collaborative work of a lot of people, they will have a banner at the top of the page asking for specific improvements. Right, so that's a flag that this is probably not so reliable. An indication that the page is reliable is that there's lots of activity on the view history page. So every Wikipedia page has a view history page. If you go to the Wikipedia page, there'll be a view history, and there you can see all the edits that have been made. So if there's a lot of activity, like if there's an edit being made every day, that means that it's the ongoing collaborative work of many individuals. And those individuals hold each other accountable. So if somebody says something that's not true or cannot provide a citation to support it, then others will pick up on that and take it out. And so that's how you can judge that a page is reliable. So for instance, if you look up, I have an example here on the global warming hiatus, which is something I've lectured on in the past. That's a page that has lots of citations, is relatively reliable. So it can be a very good starting point. Okay, so that's the first approach for finding relevant references, is to use Wikipedia or semi-scientific media as a starting point. So commentaries in Science and Nature, for instance, if you will get a hold of those, are also a good starting point. So the second one, of course, and that's especially more relevant as you've scoped your topic a little bit, is to search for journal articles relevant to your research question. And here Google Scholar is fantastic, and it's free. So for that, you want to create a search strategy. I mean, you can't just start typing things into Google Scholar. That works okay, but it's better to be a bit organized. So you want to identify your topic. For instance, if you're interested in the link between climate change and hurricanes, which is a very active and important area of study right now, then you can come up with a search equation that will make your search much easier. So first is you want to find synonyms of or related terms for each keyword. So a synonym for climate change would be global warming. A synonym for hurricanes would be tropical cyclones. And then you use a Boolean operator to link the terms. So in other words, the word and or. Right, so if you're, for instance, example here, children and television, if you link those with the word and, you're just going to find articles that mention both.
Mm-hmm.
So then you create a search equation. So you have your two concepts, you link all the synonyms with the word or, and then you link the concepts with the word and. You can do this with as many concepts as are in your specific area of study, and the more detailed it is, the more search words you might have here, and the more synonyms. And then you get from that your search equation. So a good search term for this would be, open parentheses, climate change in quotes, or global warming in quotes, close parentheses, and then the Boolean operator and, so just the word and, hurricanes or tropical cyclones. So that make it such that any article that mentions either climate change or global warming and hurricanes or tropical cyclones will pop up. So if you do that, you get this. And Google Scholar is nice in that it will show you what it thinks are the most important articles, which are usually those that have been cited tremendously. So you see, 1900 citations at the top. Tropical cyclones and climate change, the second entry. That's probably the most well-known review article on this. So that would be, for instance, a great place to start. And there's a number of other, important and highly cited papers after that. So that's a great way to locate, the papers that you want. So now you want to obtain those. If your institution has a subscription to something like Web of Science, that should be fairly straightforward. If it does not, you can look through Google Scholar. So you can look at here the 25 versions. Likely one of them is freely accessible. These include things like PDF versions of the article that authors will post on their website. Sometimes, though, there is no freely available version through Google Scholar. Then a great approach is to use researchgate.net. So a lot of scientists are on, this is sort of Facebook for scientists. So if you enter the article title in ResearchGate, then if one of the authors of the paper is on ResearchGate and has posted a version of the article, you can freely access it. So I think at least half of the articles would be available there. And if that doesn't work, you can contact the authors. We've gotten lots of papers that way, especially old papers that are not online. You know, find the authors, find their email address, and ask for a PDF. Almost all scientists love to share, obviously, their work, so very likely you'll get the paper back in response. Okay, I saw one question about that hurricanes should be in quotes. We should have gone over this. I did not. Okay, so the quotes are there if you have a term that is more than one word. If you don't put the quotes there, it will find articles that have climates and change in them, but not necessarily in that order, in the order of climate change, which is what you want in this case. You know, just like you want tropical cyclones in that order rather than the article talking about cyclones in one place and then tropical in another place. So that's why the quotes are there. And that's why hurricanes or any term with this one word does not have to have quotes. You can put it there, you know, it won't do anything. And the parentheses are there to make sure the search contains one term from concept 1, so what's in parentheses, and one from concept 2 in parentheses. I think that is it, actually, yeah.
Any question? Thank you so much, Jasper.
Sure.
Any question?
Saw a chat come up. Okay.
Any question? Did you mute already?
Okay, if there are no questions. Sure.
All right. So I was gonna say that for some of you, and I know this because I've hear from people that ask me to help them download some papers. So I want to mention that if you say, for example, you're doing your thesis or your research, and there are some papers that say your university doesn't have access to, or you probably contact the ResearchGate author and they're not sending the paper, maybe too early for you, I think you can use our platform here and Environmental Science Without Borders to ask for those kind of papers. So if you can post it to any of the communication, say WhatsApp or on our Slack, or send an email. And if our university here have access to it, it's a thing that we think we can do, help you download that paper in PDF form and send it to you. So I just want to say that out, just in case any of you have that. So any other question?
So there's a question about searching the library. You know, I used to do that when I did my PhD. I think nowadays, I haven't been to the library in a very long time. So I think almost everything is online, but it obviously depends on your library. If your library has a lot of articles that go way back, it might be useful, but I think it's the exception. I think almost everything is online now, and it's more time efficient to find it online.
Hello. Are you hearing me?
I see. And so there's a comment that 1970 through 1990 are only in the library and not in the database. I think that depends on the journal. Certainly Google Scholar goes, you know, well back to certainly before 1970, as far as I'm aware. Maybe somebody else knows more about that. But whether the PDF of a paper is available depends on the depends on the journal and whether your library has a subscription to that journal. I think certainly the good journals in my field usually have PDFs online back to 1970 or so. But yeah, if that's not the case, you can try the library. But it depends on, of course, how much your library has versus online.
All right, yeah, I think you have a question, right? Any other questions? Remember that you can unmute yourself if you have a question. Well, I just want to say thank you to Jasper, Dr. Jasper Kok, for presenting this and letting us know a little bit about some of these salient points that seems a little bit abstract. I've sent out the link to the site in the chat, but I'm going to email it to everyone after the mailing today. But again, keep in mind that you can always send questions and get back to us if you have any question. I think Nee is asking a question here, right?
Yeah, so is there any standard length for an introduction in the manuscript in terms of number of words or paragraphs? The answer is no. There's no standard length. In general, though, your introduction should, it should start broad, sort of identify the bigger question, and then focus in on your research question and why there's a gap there that you're trying to fill. So usually introductions are something like maybe 4 or 5 paragraphs. If it's much longer than that, it's you're probably writing too much.
Another follow-up question is, how different is the thesis introduction compared to a typical paper's introduction? Is it typically similar in the way you write it, or should there be some differences?
Ooh, that's a good question. Yeah, so thesis introduction, scientific novels. Okay, I'll answer that question after this. But a thesis introduction is quite different, I would say. So scientific literature is meant to present one advance, and so the introduction is written just to frame and introduce that gap in literature that is being filled. For a thesis, you do generally want to do a literature review in the introduction that is broader. I don't have any really great guidance on that. That really depends on your advisor, on what they expect from that. Yeah. The next question, I need further clarification on the statement scientific papers are not novels. That's great. So knowing duly well, our manuscript should be explanatory to a layman. Or do I get something wrong? That's right. So I presented, this was about reading scientific literature. And so if you're trying to read it, the point is that you should not read it as if it's a book. I muted myself a little. Okay. You should not read it like it's a book, because then you're wasting a lot of time, because things like methods and sometimes results are useful only to that small group of scientists that are really, really interested in this paper and want to perhaps use parts of the methodology.
So that's why I'm saying for most papers, you probably want to get the main part.
And there's no need to read the whole paper.
So you read the abstract, you
go over the figures, and that will take you maybe half an hour. Whereas reading the entire paper and understanding everything, that takes you a day. Right? So you should be really selective in what papers you do that for. Right? And even those papers, first, you should read the abstract, then look at the figures, then the introduction, then method, then results, then discussion. That's, for most people, the most efficient way of reading a paper. Hope that answers your question. Are there any more questions?
Yes. Hello, are you hearing me?
I can sort of hear you.
Yes, go ahead.
Okay. Please, in addition to the question I've asked, in this part of the world, we do have a challenge in terms when they are trying to write manuscripts. That's in the aspect of plagiarism. And it's not that we are not conscious of it, but because of summarizing a lot of related articles, only thought and introduction
I can
to the discussion.
No.
Are you hearing me?
Hello, can you hear me? Hello?
Yes, I can hear you. Can you hear me?
Yeah. There's the echo. Can you hear me now? Good? Yeah, I need to put on the.
Yes, I can hear you. Should I go ahead? Hello?
Hello, can you hear me now?
Yes, I can hear you now.
All right, perfect. All right, so can you repeat your question?
Okay, the question is that in this part of the world, in course of trying to summarize a lot of related manuscripts to form a thought in phase of introduction and discussion, we do have a challenge of plagiarism. And it's not that we don't have that in mind, but because we don't have access, or our institution doesn't have access to like turn it in. So I don't know, is there any platform that can come up with a similarity index to avoid plagiarism when we are trying to put together our thoughts in writing our introduction or developing our manuscripts?
Could you understand?
I think if I get your question correctly, is that you say you have challenges with plagiarism, right? And your question is there any platform that can help you avoid plagiarism? Is that the question?
Yes, more like a platform that can help us to like confirm whether we are on track in avoiding plagiarism or not, apart from the commercially available turnitin.
Okay.
So the question is there available software that detects plagiarism so you can avoid it?
So that you don't the papers is not, it doesn't show that it's plagiarized because because of the limited resources as far as getting papers are concerned. It says that it appears that there are papers sometimes that things get flagged up that shows that it's been plagiarized or something like that.
Right.
So is there a way to kind of check the document before to avoid plagiarism?
That's a good question. There is. I don't know exactly. There's something, I use as an instructor called Turnitin, but I think that is for institutions only. Like UCLA has a subscription to that. Yeah, so I don't think I can answer the question. I know that journals use plagiarism software to detect it, but I'm not sure how, as an individual, you can check. I'm sure there is software, but I'm not sure if there's free software. But your institution might have it.
Just as to add to what Jasper just said, I think what you should always do is that whenever you're reading a paper and you're picking something out of a paper, don't use the exact same word. Just make sure that you read it and understand it and rewrite it in your own language, in your own sentence.
Yes.
So that way, even if something flags up, you'll be sure that you didn't plagiarize anything because you wrote it down in with your own English. You know what I mean? So
right. Yeah, never copy.
Never copy paste.
Yes.
Well, I think we're gonna leave it there. Thank you so much, everybody that's part of the meeting today. Really appreciate it. So please let us know if you have any other comments or questions later on. One other thing I want to briefly say before I go is that we are open to you suggesting topics that you would like us to cover, topics that either relates to your research or has things to do personally as far as environmental sciences is concerned, that you think that is going to be good for this platform to talk about, and then we can invite an expert that's going to talk about it. So please send me an email or WhatsApp or on Facebook or wherever, and just let us know what's going to be a good topic that you'd like to hear, okay? Does everybody hear me?
Yes.
All right. All right. Thank you very much. Thank you so much for the meeting, and I appreciate it, everybody. Please do have a great day. I hope we didn't stay too long. Have a great time, everybody, and thank Jasper for giving us a great talk here today. Bye.
Bye, everyone.
Bye, Bastien. Bye, everyone. Bye, Marie.
It was very nice to have a talk, as always. I think we need to have talk every time. And a different,
Sure. If you can always be available every time, I will talk to you, no problem. We'll talk to you.
Thanks very much for the presentation.
Anne, I think you want to say something, Anne?
Oh, I just wanted to say thank you and good to see everybody, and thank you so much for the presentation and to see everyone. Great. Thank you.
Thank you. See you, everyone. Bye. Bye. Bye, Arlene.
Bye-bye. Thank you.
Bye. Thanks, Jasper.